In the world of DevOps, build and release pipelines are essential for automating the process of software delivery. These pipelines ensure that code changes are automatically built, tested, and deployed to various environments. This not only speeds up the development process, but also ensures consistency and reliability. In this presentation, we will delve into complex pipeline scenarios, including hybrid pipelines, VM templates, and self-hosted runners or agents. By the end, you'll have a comprehensive understanding of how to design and implement these advanced pipelines. Hybrid pipelines combine different types of environments and tools to create a seamless workflow. For instance, you might use cloud-based services for some stages of your pipeline and on-premises resources for others. This approach allows you to leverage the strengths of both environments. Hybrid pipelines are particularly useful in scenarios where data residency, compliance, or specific performance requirements dictate the use of on-premises resources. We'll explore how to set up and manage these pipelines effectively. Virtual machine VM templates are pre-configured virtual machines that can be quickly deployed to create consistent environments. These templates can include all the necessary software, configurations, and settings required for your build and release processes. Using VM templates ensures that every instance of your pipeline runs in an identical environment, reducing the risk of inconsistencies and errors. We'll discuss how to create, manage, and deploy VM templates in your pipeline. Self-hosted runners, or agents, are machines that you manage and maintain to run your pipeline jobs. Unlike cloud-hosted runners, self-hosted runners give you more control over the hardware and software configurations. This can be particularly useful for running jobs that require specific dependencies or higher performance. We'll cover the benefits and challenges of using self-hosted runners and how to set them up in your pipeline. Hybrid pipelines offer several advantages, including flexibility, cost efficiency, and compliance. By combining cloud and on-premises resources, you can optimize your pipeline for different stages of the development lifecycle. For example, you might use cloud resources for scalable testing environments and on-premises resources for secure deployment stages. This approach allows you to balance performance, cost, and security requirements effectively. Creating VM templates involves setting up a virtual machine with all the necessary software and configurations, then capturing its state as a template. This template can then be used to deploy new VMs quickly. We'll walk through the steps of creating a VM template, including installing required software, configuring settings, and capturing the VM image. We'll also discuss best practices for maintaining and updating your VM templates to ensure they remain current and secure. Once you have created a VM template, the next step is to integrate it into your pipeline. This involves configuring your pipeline to deploy new VMs from the template at the appropriate stages. We'll explore how to automate this process using infrastructure as code tools like Azure Resource Manager, ARM templates, or Terraform. By automating VM deployments, you can ensure that your pipeline environments are consistent and reproducible. Setting up self-hosted runners involves provisioning a machine, installing the necessary software, and configuring it to communicate with your pipeline orchestration tool. We'll provide a step-by-step guide to setting up self-hosted runners for popular CI/CD tools like GitHub Actions and Azure Pipelines. We'll also discuss how to manage and scale your self-hosted runners to handle varying workloads effectively. Managing self-hosted runners requires ongoing maintenance to ensure they remain secure and performant. This includes applying software updates, monitoring resource usage, and scaling the number of runners based on demand. We'll discuss best practices for managing self-hosted runners, including automation strategies for scaling and maintenance. By following these practices, you can ensure that your self-hosted runners provide reliable and efficient execution of your pipeline jobs. Security is a critical aspect of any pipeline, especially when using hybrid environments, VM templates, and self-hosted runners. We'll explore the security considerations for each of these components, including network security, access controls, and data protection. We'll also discuss how to implement security best practices to protect your pipeline and the applications it delivers. Ensuring robust security measures will help you mitigate risks and maintain the integrity of your software delivery process. Effective monitoring and troubleshooting are essential for maintaining the health of your pipelines. We'll discuss the tools and techniques for monitoring pipeline performance, identifying bottlenecks, and diagnosing issues. This includes using logging and monitoring tools like Azure Monitor, Prometheus, and Grafana. By implementing comprehensive monitoring and troubleshooting practices, you can quickly identify and resolve issues, ensuring smooth and reliable pipeline execution. To bring all these concepts together, we'll examine a case study of a hybrid pipeline implementation. This case study will illustrate how a fictional company leveraged hybrid pipelines, VM templates, and self-hosted runners to optimize their software delivery process. We'll explore the challenges they faced, the solutions they implemented, and the outcomes they achieved. This real-world example will provide valuable insights and practical tips for implementing similar solutions in your own organization. In conclusion, designing and implementing complex pipeline scenarios like hybrid pipelines, VM templates, and self-hosted runners can significantly enhance your software delivery process. By understanding the benefits, challenges, and best practices for each component, you can create robust and efficient pipelines tailored to your organization's needs. As a next step, consider experimenting with these concepts in a test environment to gain hands-on experience. Continuous learning and adaptation will be key to mastering these advanced pipeline techniques.